guys, welcome to my channel. This afternoon we'll be talking about HUND'S rule. And what is HUND'S rule? And before I state HUND'S rule, I also expose you guys to what we call electronic configuration. And in atomic physics and quantum chemistry, these two, we are meant to know that electronic configuration is the distribution of electrons in atoms or molecules in molecular orbital. So quantum atomic physics and quantum chemistry make us to understand that for every electronic configuration they must undergo what we call equal distribution of electrons in atoms. So with that, we must touch what we call Aufbau principle. And what is Aufbau principle? Aufbau principle states that you must fill in the lower energy before the higher energy. So lower energy before the higher energy. I said it now. Aufbau principle states that you must fill in the lower energy before the higher energy. So let's take the illustration in which Aufbau principle gave us. So we have 1s, we have 2s, we have 2p, 3s, 3p, 3d, 4s, 4p, 4d. So I will stop here. We have it from 1 to 7, but because I'll be dealing only with the first 20 elements, so I'll stop under the word the 4d, 4. So we have this arrow. Once I have this arrow, we have this arrow like that. We also have what we call the 5s, 5p, 5d, and 5l. So this arrow goes like this. So how do you relate this to electronic configuration, Aufbau principle? And let's show you that with this we can tell you that there's equal distribution of electrons in an atoms, and also you must also fill in the lower energy before the higher energy. And note one thing before we continue. We have what we call the S, P, D, F. So for this S, they can only contain 1 to 2 electrons. With this, they generate orbital 1, 2. That's the 2 electron. For P, 1 to 10, they have this, they generate orbital. And don't forget, our P can be divided into, our P 1 to 6. This generate orbital can be divided into 3. We have the Px, the Py, and the Pz. So we have 1, 2, 3, 4, 5, 6. Why our D can contain electron from 1 to 10, and our F 1 to 14. For this D, we have this direct orbital. Why for our F, we have this degenerate orbital. Are you with me now? So guys, let's relate all these to what we call HUND'S rule. And before I move to that HUND'S rule, I would love to show you guys the first 10 electronic configuration. So we have hydrogen with atomic number 1, helium 2, lithium 3, beryllium 4, boron 5, carbon 6, nitrogen 7, oxygen 8, fluorine 9, and neon 10. With these first 10 elements, let's check out their electronic configuration using Aufbau principle. That you must fill in the lower energy before the higher energy. So with hydrogen having one atomic number, the first one we have here is 1s, so it's going to carry what? 1s. Helium, 1s2. Lithium, we have 3s, so 1s2 is not possible for this one to carry 3 electrons. Rather, it's going to take only 2. Then move the second one to 2s. So we have 2s1. For beryllium, same thing, 1s2, 2s2. Until you have filled up this before you can move to 2p. So let's look at boron. 1s2, 2s2, 2p1. For carbon, we have 1s2, 2s2, 2p2. And this, we have 1s2, 2s2, 2p3. For oxygen, we have 1s2, 2s2, 2p4. 1s2, 2s2, 2p5. While for neon, we have 1s2, 2s2, and 2p6. You can say the first 10 elements using the Aufbau illustration. So let's state what we by Ohm's rule. Ohm's rule states that electron, the first one, must be equally distributed before pairing occur, or electron must be singly filled before pairing occur. So how do we relate this particular rule to this, and what? This. I'm going to pick out two elements for the first 10 elements here. So the first one is nitrogen with atomic number 7. So we have the electronic configuration to be 1s. So go back to your SPDF orbital. So the first box for that is this. We have 1s. And the element here is 1, 2. The next one, 2s, 1, 2. And the last one is p. So we have 3 there. If you are to fill in your orbital, your 2p orbital like 1, 2, 3, like this is wrong, because we did not follow the Ohm's rule that electron must be equally distributed before pairing occur, or electron must be singly filled before pairing occur. So let's check out the correct one. Pick our p orbital, 1, 2. Mind you, for nitrogen the outer electron is 3, so you are going to distribute it equally. 1, 2, 3. Another element, carbon. We have 1, 2, 1. So this will our 1s, our 2s. Then the p for carbon. So the outer electron of carbon is 2. So if you have 1, 2, wrong, because you did not follow the Ohm's rule that electron must be equally distributed. So let's check out the correct one. We have this. These 2 electrons you pack together in this box must be equally distributed. So we have 1, 2. So this is correct, and that is what? Correct. That is for Ohm's rule. And note that in Ohm's rule, electron in a subshell must be paired, or before they paired with other elements or electrons, they must undergo what we call parallel spin. So he said, note, electron in a subshell is paired only when the orbitals of a subshell is half filled with parallel Spain. You must take note of this. Thank you for watching. Don't forget to subscribe.